Very good morning to all. I am Dr. Devasis Mohanty, working as Assistant Professor in the Department of Mathematics, SR University, Warangal, India. So today I am going to teach you about the t-test for single limb. Means how we can use the t-distribution table and how we can find the value if the single mean is given. So let us discuss the today's lecture. So students, this is all about the this, use of that. So let us see about that. So here, use to test whether the mean of a single sample differs significantly from the hypothesized population mean. So that is very important. Differ from a hypothesized population mean. In the second step, we have to see the appropriate when population standard deviation is unknown. So it is always appropriate when population standard deviation is unknown. Right? In the third step, sample standard deviation is used as an estimate. That is very important. The sample standard deviation is, is used as an estimate. Okay. Then based on the p-distribution, which is suitable for small sample sizes, that means n is less than 30 for that case only. N is less than 30, that is used based on the p-distribution. Based on the p-distribution. And which is suitable for small sample size. That means n is always less than 30. So we have to see accordingly. So students, next coming to the important thing, that is the assumptions of the t-test for single mean. So what are the assumptions? And the first assumption, that is the sample is drawn from a normally distributed population. So it is always drawn from a normally distributed population. The sample is random and independent. The sample is random and independent, not dependent. The population variance is unknown and estimated from the sample. So population variance is unknown and estimated from the sample. Right. So these are the basic assumptions of the t-test for single mean. Okay, students. So next, coming to the point, formulation of hypothesis. So in the first formulation, we have to see the null hypothesis. So here we can see the null hypothesis. Means it's not such that mean is equals to mean not. Means sample mean is equal to hypothesized mean. Sample mean equals to hypothesized. Right? In the second one, alternative hypothesis. H1 such that mu is not equal to mu naught. That is 210. That is 210. That means mu is greater than mu naught or mu is lesser than mu naught. Both the cases we can consider the alternative hypothesis, and in the first case we can compare the null hypothesis. We can take the null hypothesis as mu is equal to mu naught, and alternative hypothesis as mu is not equal to mu naught. So here mu is not equal to mu naught means that is true trend. Either mu is greater than mu naught or mu is lesser than mu naught. So students, after that, very important, that is the test statistics formula. So here the test statistics under the null hypothesis x naught, and the formula is t equals to x bar minus mu naught divided by s divided by square root of n. This is the formula. By this way you can test statistics under x naught. Right? Next is so by this way you can find the t value. Where x bar is the sample mean, this one x bar is the sample mean, mu naught is the population mean, s is the sample standard deviation, and n is the sample size. And always, as I discussed, students, degree of freedom. Here we need to calculate the degree. Whenever t distribution will come means we have to calculate the degree of freedom, that is equal to n minus 1. Right? So coming to the first example, a manufacturer claims that the mean lifetime of its bulb is 1200 hours. So mean lifetime of its bulb is 1200 hours. And a random sample of 10 bulbs. So n is given 10. That is the random sample. And that mean is given 1150. That is x bar value. This is the mu value. Right? And the standard deviation, this sigma value is 80 hours. So we have to test the claim at 5% significance level. 5% significance level, right? So students, here we can see the solution. In the solution part, see the first step, that is the step 1. In the step 1, x naught is given, mu is equal to 1200, and the alternative hypothesis h1 such that mu is not equal to 1200. Then we have to compute the test statistics, means t value. So how to compute that? X bar minus mu naught divided by x bar minus mu naught divided by s divided by square root of n. That is 1150 minus 1200 divided by 80 divided by square root of 10. This value, that is equals to, nearly equals to minus 1.98. Right? So after calculating this t value, we have to see this degree of freedom. So students, now tell me, what is the degree of freedom here? The sample size is given 10. So for given sample size 10, the degree of freedom will be here 10 minus 1, that is equals to 9. Right? After calculating the degree of freedom, we have to check the critical value. So here the critical value at 5%. 5% means 210. 210 means one is equal, another is not equal. That is equivalent to plus or minus 2.262. That is from the table. Right? So in the step 4, means in the final step, we have to check this statistics value, means using the t distribution. This, what is the statistics value? Minus 1.98. So is minus 1.98 lying between 2.262 or plus or minus 2.262? We have to check there. Is it lying? If it is lying, we fail to reject the null hypothesis. Obviously, it is lying. So We fail to reject the null hypothesis as minus 1.9 as minus 1.98 is less than minus 2.262. So we fail to reject null hypothesis H naught. Fail to reject means what? No significance difference. No significance difference of the claimed mean. Okay. So by this way we can use the t distribution and we can easily calculate whether we reject the null hypothesis or fail to reject the null hypothesis. And after that, if we fail to reject the null hypothesis, there is no significance difference of the claimed mean. And if we reject the null hypothesis, means there is a significance difference to claim means in the claimed mean. Right. The students coming to the second, this is the t-test table. T-test table means here we see that statistics value at degree of freedom 9, how will get 2.262 here at 9. So here you will see this is the 9, degree of freedom is 9. So in the ninth row, we have to see at 0.95%, means 5% confidence level, this value. This is 5%. 2.262. This value we are getting 2.262 means as this is a 0.05. This is total and 0.05. At 9 degree of freedom, we are getting using this T distribution table, we are getting the value 2.262. So according to the degree, this is the list of the DF. DF means degree of freedom. These are the degree of freedom, and this is the means T distribution details. T distribution. And if using this T distribution, we have several values based on that. So we can easily calculate these values, right? This confidence level. So here it is starting from the Z at 0%, 50%, 60%, 70%, 80%, 90%, 95%. This is a 95% confidence level. So we follow this entire column for 95%. Right. And then 98%, 99%, 99.8%, and 99.9%. So student, so my main motto is to influence you, like how we can calculate this critical value using t table. This is the basic thing by which we can calculate the t table, t-test table. So after this, coming to the another problem. The problem is given. A nutritionist claims that the average daily protein intake is 60 grams. So try to read the question carefully, then we'll discuss. Yes. A nutritionist claims the average daily protein intake is 60 grams. A sample of 16 individuals shows a mean of 65 gram with a standard deviation is 8 gram. Right? So test the claim at 1% significance. So try to understand this question. Two means are given. First is given 60, another is given 65. Right? And 16 individuals means n value is given 16. Right? And standard deviation this sigma value is given h or s value. S is equal to h because it is small. So at 1% confidence level, we have to check. Right? We have to test the hypothesis. Let's coming to the solution part. So this is the solution part, students. Starting with the hypothesis that H naught value, H naught is such that mu is equal to 60, and the alternative hypothesis H1 such that mu is not equal to 60. That means the mean is for one case the mean is 60, and for another case, alternative hypothesis case, the mean is not equal to 60. So after that, we will test the statistics. Means how we will test? Now we use the t distribution, that is x bar minus mu naught divide s divided by square root of n. So that we can apply the formula 65 minus 60 divided by 8 divided by square root of 16. That is 5 divided by 2, that is 2.5. Okay, students. So after computing this, we have to, in the third step, we have to see the degree of freedom. So here, the degree of freedom, how to calculate it? Total sample size minus 1. So here the sample size is given 16. So degree of freedom is equal to 16 minus 1, that is 15. Right? Next, we have to check that it is a two-tailed or one-tailed test based on that critical value. So critical value is 1%. Critical value at 1%. 1% means two-tailed. Two-tailed means that is nearly equal to plus or minus 2.947. That we will get from the table. Right, students? Since we are getting these values, we have to check we will reject the null hypothesis or fail to reject the null hypothesis. So if this value is lying in between them, then we reject the null hypothesis, or else we fail to reject the null hypothesis. Right. So here we have to see since 2.5 is less than 2.947, so we fail to reject. It's not. So fail to reject H naught means null hypothesis. So our conclusion is no significance difference. No significant difference at 1% level. Right? Because already we have the t value and already we have the H naught value. So in the first step, we have to define the null hypothesis and alternative hypothesis. That is, one case is equal mean, another case is not equal. After that, we have to test the statistics in t value based on the formula x bar minus mu divided by sigma divided by square root of n. And there we'll get that is 5 by 2, that is 2.5. After that, we have to calculate the degree of freedom. So how to calculate the degree of freedom, students? N minus 1, that is 16 minus 1 is 15. And after calculating the degree of freedom, we have to calculate the critical value. Critical value means from the t table. So here you have to see how we'll calculate this critical value. So how much we are getting? 2.947 means 1% confidence level, and degree of freedom is 15. So we have to see 15, 2.947 at 99% confidence. So here 99% means this one. We have to check this one at 15 value. At 15 value, we have to check this one. So what is that value? 2.947 means 99% confidence level. So here the 99% confidence level, and here the value is 2.947. Alright, students? So 2.947 means that is at 15 degree of freedom. Means here the significance two-tailed test at 0.01 significance level. Okay, right. So using that only, we have to calculate this value. Next, coming to the next problem. Here is one interesting example is there. So the example is explaining that a manufacturer claims that the average life of a battery is 100 hours. So average life of a battery is 100 hours. A random sample of 10 batteries is given. So random sample of 10 battery gives the following. X is equal to 96 hours and standard deviation S equal to 8 hours. The tests are 5% significance level. 5% significance level. We have to test. Okay, students. So here sample mean X bar is given 96 hours. Standard deviation S is 8 hours, and the 10 batteries is given. Average life is 100 hours is given. So we have to test at 5% significance level. Right? So coming to the solution part, the first step is we have to state the hypothesis, right? So we have two hypotheses there. One is null hypothesis, one is alternative hypothesis. Null hypothesis is given mu is equal to 100. Alternative hypothesis is given h1 such that mu is not equal to 100. That means it is a two-tailed test, right? Two-tailed automatically because one is given equal and another one is given not equal sign. Then after defining both hypotheses, mean null and alternative hypothesis, we have to test the statistics. How to test the statistics, students? Yes, tell me. Now we have to calculate this t value. How to calculate that? X bar minus mu divided by s divided by square root of n. So by that only you can calculate the t value. And you can substitute this value. So here x bar is given 96, mu is given 100, s is given 8, n is given 10. Those data are given in the question, right? Next, we have to calculate the t value. So how we can calculate the t value? Here, this t value is equal to 96 minus 100 divided by s is 8 divided by square root of 10. So that is minus 4 divided by 8 divided by 3.162. So that is minus 4 divided by 2.53. That is minus 1.58. This value is given minus 1.58. So this is the t value actually. T value is minus 1.58. Okay. After defining this t value, we have to calculate the degree of freedom. So degree of freedom, how to calculate that? And degree of freedom df equal to n minus 1. df equal to n minus 1. So df equal to n minus 1, what is the n value? N is given 10. So df equal to 10 minus 1, that is 9. And after finding this df value, we have to construct the t table at 5% level. Means 5% level means two-tailed, right? So how to find that? Means we have to calculate the t critical value. So how to calculate the t critical value? So using this table at 5% level of confidence, we have to see here. Yes, 5% means 95% confidence level. And what is the degree of freedom? Same, degree of freedom is 9. So here the same value, 2.262. The same value we are getting 2.262, right? So that's why the critical value is given there. That is T critical equals to 2.262. Because degree of freedom is 9, we have already calculated the degree of freedom, that is at 9, and significance level is 5% significance level. So alternative, so obviously we are getting this critical value as 2.26. So students, after finding this, we have to find the modulus of t because we have to take the positive values only. So as the t value we are getting negative, so to construct the decision, we have to find the modulus of t, that is 1.58. And 1.58 is lesser than 2.262. So as it is lesser than that value, so that we don't reject the null hypothesis. Why we will reject the null hypothesis? Because this value is lying in between those values. So that's why 1.58, as 1.58 is less than 2.262, so we don't reject or fail to reject the null hypothesis, or else we fail to reject the null hypothesis. Okay, students. Then in the final conclusion, there is no significant difference between the sample mean and the claim mean. So that the manufacturers claim that the average battery life is 100 hours. That is acceptable, right? So this is all about the t-test for single mean. So stepwise I am telling. So in the first step, we have to see that we are defining the null hypothesis. This is the final decision, students. So H naught is presentation was useful, and H1 is, that means H naught is the null hypothesis, and H1 means the presentation was not useful. And test the statistics means audience feedback we are getting. Audience feedback means we have to apply the decision rule. Means if we learn something new, that means we will accept the null hypothesis. By this way, we will accept the null hypothesis. Means that is the final decision. That is the final decision. We'll accept. Means if you learn something new. And finally, conclusion we are getting there. So here it is the graph. Means here we can accept the null hypothesis. Here we can reject the null hypothesis. And here also we can reject the null hypothesis. Two cases we are rejecting the null hypothesis. Right or left? And in middle case, means whenever the distribution is coming left and right, equally normally distributed. So in that case, we are accepting the null hypothesis. Okay. So students, this is the basic fundamentals, means how we are going and how we'll test the hypothesis and how we are getting these values. Okay. So this is all about the t-test of the single mean. So again, I am discussing a few from the starting. So at the starting, we have seen is under which condition here. The condition is n is must be less than 30. This is the first condition. What is n? N is the sample size. So sample size must be less than 30 so that we can take the t distribution. Means it is only for the small samples. Okay, that is very important. And sample standardization is used to an estimate. That is the S value. Okay. So after that, we have the assumptions of the t-test for the single mean. So what are the assumptions? It is normally distributed population and it is random and independent and population variance is unknown and estimated from the sample. So these are the cases, students. And after that, we have seen about the formulation of the hypothesis. In the formulation of the hypothesis, we have seen about the null hypothesis, that is sample mean equal to hypothesized mean. And in the another case, we are is getting that value, that is alternative hypothesis, that is mu is not equal to mu naught. Not equal to mu naught. So not equal to mu naught means we are also getting these values. That is means either we are getting this greater than mu naught, or else we are getting this mu is lesser than mu naught. Right? That is one tailed or two tailed based on that. And after that, we have some assumptions of the t-test for single mean. That is either where sample is drawn from a normally distributed population and the sample is random and independent. Random and independent means randomly we can select the sample and it is always independent. And population variance is unknown. As the variance is unknown, that standard deviation we can calculate easily. Easily, no? Yes. And we can estimate it from the sample also, from the sample itself. After that, we have to formulate the hypothesis, means based on the H0 and H1. This is very important, students, because by this way we can test the statistics. So if we forget this formula, so that then we cannot solve this t-test for single event. So this formula is very important. Again, I am repeating, t equals to x bar minus mu naught divided by s divided by square root of n. This is very important for your examination. So X bar is sample mean, don't be confused, and mu not is population mean. So what is the difference? With respect to the sample is given means sample mean. With respect to the population is given means population mean. Right? And S is the sample standard deviation. Already the standard deviation will be given in the question. Either it may be variance will be given. So if variance will be given, we can find the standard deviation by the square root of the variance. And n is the sample size. So whatever sample size we are taking, that we can determine by n value. After determining the n value, we have to see the degree of freedom. What is the degree of freedom is given. So degree of freedom we can calculate by applying the df, that is equal to n minus 1. Right? So after that, we can calculate the critical value. Like here, we can calculate the critical value by using the t distribution table, that is df equals to n minus 1. Okay. After calculating this, some problems also we have discussed based on this t distribution. So students, this is all about the t distribution for single mean. So these problems already I have discussed with you how to use this table also, because this using this table also very important for your examination. Means how will they implement these values, means at a certain degree of freedom and at a certain confidence level how you are getting these values. So already I have discussed with you. Please follow up that to write the answer in the examination. Next, some examples also there. So these example also we have followed. So this is all about the t-test for the single mean. So thank you all. Thank you for listening this lecture. Next class we will discuss further. Thank you. Thank you. Thank you for listening.